Okay, so year 12, for today, I thought it might be worth doing some revision of this topic, which is modelling. So modelling is basically taking some maths that you know and applying it to real life situations. And specifically, it's kind of come up this year in three main topics. It's come up in the context of like straight line graphs, it's come up in the context of quadratics and quadratic graphs, and also in terms of differentiation. Now, often, although the actual maths is not too tricky, it's kind of reading what the question's asking you to do can cause people to get like completely overwhelmed and not know where to start. So in this video, I'm going to go through kind of a modelling question from each of these areas, and hopefully that'll be helpful, and then there'll be some practice for you to have a go at. So, first type of question is modelling using a linear model. Okay, now this word linear model will come up quite a lot. It's super important. Linear means straight line graphs, y equals mx plus c. That's going to be super important here. Now let's just read everything we've got going on. So a tank contains water, blah, 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 leaks from hole, volume of water, 24, and 4, that feels important, 60 minutes, 2.8, great. After that, the volume of water, V, in the tank T minutes after the leak started can be described by a linear model. Now, because it's being described as a linear model, that means effectively we can model it using this y equals mx plus c formula. However, because rather than having x and y, we've got v and t. For part A, my formula is going to be something like v equals, then it will be, I'm going to call it a t plus b. I've chosen a and b reasonably arbitrarily. It doesn't really matter what letters you use, but basically v is our volume, which would kind of be our y. T is the time, which would be our x, and I've just gone for a and b. That's kind of the more standard way for modelling, but all this is kind of a rewriting of y equals mx plus c. So now we've got enough information to start finding the values of A and B, because we are told the volume of the water in the tank, so the volume 24 minutes was 4 meters cubed. So the volume is 4, the time is 24, so 24A plus B. That's kind of equation 1. Equation 2 would be 2.8, because that's the volume, equals 60, because that's the time, A plus B. Now it looks like that we've got a pair of simultaneous equations that can be solved. I'm going to do 1 take away 2. When I do that, I get 1.2 equals minus 36A. So therefore A equals minus 1 over 30. We're now just going to solve to find what B would be. Blah, blah, blah. Let's substitute that into our first equation. So with equation 1, we can rewrite that as 4 equals 24 lots minus 1 over 30 plus B. So then we get 4 equals minus 0.8 plus B. We can add 0.8 to both sides, giving 4.8 equals B. And after that, we just put that all together to write our equation linking V and T. So my final answer for part A is going to be V, the volume, equals minus 1 over 30 T plus 4.8. And that's part A done. Part B of the question, part I. Use this model to find the initial volume of the water in the tank. So the initial volume at this point, T equals 0. So when T equals 0, we substitute T equals 0 into our equation. And when we do that, we just get V equals 4.8. And I'm just going to write it as 4.8 meters cubed. Part 2, use this model to find the time taken for the tank to empty. So when the tank is empty, the volume will be 0. So when the volume is 0, we get 0 equals minus 1/30th t plus 4.8. So then we get 1/30th t equals 4.8. And so therefore t equals, I'm going to times both sides by 30, is 144. And because, let's just think, it's going to be in minutes, our unit. So it takes 144 minutes for the tank to empty. Okay. So that question there is a question to do with modelling, and it's to do with modelling within a linear context. Okay, year 12. So with this then, we're still working on modelling, so that's sort of applied type question, but looking at it within the context of quadratic and quadratic equations. So we are told that a spear is thrown, blah, 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 from the top of the tower. Fine. The height in meters of the spear, okay, is modelled by this function here. Now, part A says interpret the meaning of the constant term 12.25 in the model. I'm just going to sketch kind of a graph showing what's happening. So the y-intercept of my graph would be 12.25, and the shape of the graph would look something like this. Okay, and that makes sense. So here is our tower, spear gets thrown, goes up a bit and then goes down and hits the ground. That's what's going on here. Now the y-intercept is 12.25. I know the y-intercept is 12.25. And so because of that, this 12.25 is the height of the tower in meters. So it's really important for this type of question that you give your answer in the context that you're being asked. Okay, so the 12.25 is the height of the tower in meters. My handwriting is horrible there, sorry. Right, then part B, after how many seconds does the spear hit the ground? So when the spear hits the ground, the height of the spear will be 0. So we would get 0 equals 12.25 plus 14.7 t minus 4.9 t squared. That's a quadratic equation. This type of question, I would 100% recommend that you're using your calculator. So put it into its quadratic equation mode. I'm just doing that now. So when we put that in, A is minus 4.9, B is 14.7, C is 12.25. And when we do that, we get either t equals 3.68, or we get t equals minus 0.67. Obviously, only one of those solutions can be correct. Which of those solutions must be correct is this one. T equals 3.68 seconds. Right, part C. What are we being asked to do here? Right, write HT in the form A minus B, T minus C squared, where A, B and C are constants to be found. Right, what we want to be doing is recognising what this form is. So this form here is our completed square form. We want to complete the square, so that's the expression we've got. So to complete the square, I'm first of all going to rewrite it as minus 4.9 t squared plus 14.7 t plus 12.25. After that, to complete the square, I'm going to take out minus 4.9 as a factor. So get minus 4.9 t squared, and then this would be 14.7 divided by minus 4.9. This would be minus 3t, and then that final term would be minus 2.5. Now it's written like that, we're able to complete the square. So to complete the square, my minus 4.9 is going to stay here for now. And this t squared minus 3t becomes t minus, we halve the 3 to get 1.5 squared. We take away 1.5 squared, which is minus 2.25. and then we're minusing 2.5 still. Then after that, we get minus 4.9 t minus 1.5 squared. And now in terms of this bit, so this bit at the end, this numbery bit here, we have got minus 2.25 minus 2.5, which is minus 4.75. And then when you times minus 4.75 times minus 4.9, we get positive 23.275. And so now it's written like that. All we just need to do is rewrite it. So rewritten, it becomes 23.275 minus 4.9 t minus 1.5 squared. Finally, for part D, what are we being asked to do for part D? So using your answer to part C or otherwise, ignore that or otherwise, we are just going to use our answer to part C. Find the maximum height of the sphere above the ground. So the maximum height of the sphere, if we've got this, h equals 23.275 minus 4.9 t minus 1.5 squared. The maximum height of the sphere is going to be this 23.275. Okay, because basically we can make this whole expression here equal to 0 when this whole expression here is equal to 0. The maximum height of the sphere is 23.275 meters. And then the time at which this maximum height is reached. So the maximum height is reached when this bit here is equal to 0. For this bit here to be equal to 0, the time must be 1.5 seconds, because when we substitute in 1.5, that whole thing becomes equal to 0. And so therefore, yeah, the time at which it's reached is 1.5 seconds. Right, that is a moderately long question. Sorry, I meant to highlight that in yellow and blue. That is quite a long question. I hope that has been helpful. Generally, for modelling with quadratic questions, you will need to complete the square. You will need to recognise that completed square form. That's a really, really useful thing for you to be able to do. Okay, so if you're not 100% confident on that completing the square process, please make sure you're going back over it and then speaking to me if you need to. I'm going to pause this video here just because I'm aware it's getting quite long. And I'm going to do a separate video going through some modelling differentiation type problems, just because I think that will probably be helpful. As ever, let me know how you get on with this, and speak to me if you need any more help.